Databricks is known for machine learning as well as for heavy analytical use cases, but you cannot really do something like visualizing your edge device data in near real time, right? Well, let me show you something. So I have here a Raspberry Pi connected to a temperature sensor, and I have this Databricks dashboard. And now if I come closer with the flame to the actual temperature sensor, then you should see within a couple of seconds that the temperature spikes here in our dashboard, because this is a near real-time dashboard visualizing our sensor data in a Databricks app. And as you can see, there is also a text box here with an AI assistant. And here I can ask questions like, how many spikes occurred in the last 3 hours? The Genie agent was thinking about this question and provided us with this answer here. I can dive a bit deeper and ask how spikes are actually defined. And for that, I also get an answer. And all of that was built within a couple of hours using only Databricks native tooling, using Zerobus Ingest, Lakebase, and also vibe coding this Databricks app using Cursor. So if you want to know the details how I implemented this use case end to end, then this video course is for you, because I will guide you through every single step from the data ingestion to the aggregation to storing it in Lakebase and then vibe coding the app and including this chat interface. And I will also share all of that code with you so that you can follow along and try it out yourself. Now let's start by looking into how to set up the sensor and how to push the data into Databricks using Zerobus Ingest. Now, before we start ingesting our data, we need to set up our hardware. I will show you now how I set it up with like a Raspberry Pi and real sensors. If you're not interested in that, you can also skip to the part where we start ingesting the data. And I will also attach a script that you can just use that will mimic some sensor data generation. Now, for the setup, what we need, and the way I set it up is I have a Raspberry Pi right here. What you would also need would be some jumper wires to connect the sensor. And then obviously the sensor itself, in my case, it's this tiny little one right here. So this is a BME 280. I will also put it into the video description. And then what you have to do is you have to solder this sensor to the cables, basically, if it does not come pre-soldered. Then you can directly plug the end of the cables into the default I2C ports of the Raspberry Pi. For this, I use this guide here, and you can see like where to put the cables in, and this is what we're going to do. And this is how it should look like at the end. So we have the cables connected to the sensor, and now we can basically connect into our Raspberry Pi and do some configurations there and check if we can now read the sensor data already. For this, I open a new terminal and then I connect into my Raspberry Pi. Of course, you could also just use a monitor or something to plug into your Raspberry Pi and do it from the UI. In this case, I just log into the Raspberry Pi and there we go. Now I am connected. First thing we need to check is if those I2C pins are enabled on the Raspberry Pi, because we will need those to read in the sensor data. For this, what I can do is I can execute this respconfig command. I go into the interface options here, and then I check for I2C and enable it. There we go. Once this is enabled and I rebooted my Raspberry Pi, I can already check if my sensor data is properly detected. For this, I just execute this command that you can see right here. And if it looks for you like this with the 76 right here, it means that you are properly retrieving your sensor data in the Raspberry Pi. Next, I need to install the sensor library. And for this, I do the following. I create a virtual environment and there I install this library. And there we go, I have it properly installed. I create a new file, touch demo sensor, and then I open it using Nano. And here I just copy paste some code of one of the many guides that exist to read from the sensor and to also print it into the console. Now I quit and save. Cool, and now I should already be able to execute this. And there we go. We see we are getting some data here, and this is actually printed every second now into the console. Now we can also pull up our sensor a bit closer to us. And what we can do now is we can just put our fingers onto the sensor and we should see the temperature increasing. And there we go. Cool, so all works, everything is connected. We have set everything up to capture the data from the sensor and also a small script to showcase how we can actually access it. And next, we will look into how we can push this now into Databricks using Zerobus. Traditionally, if I would want to stream some event data into my Lakehouse architecture on Databricks, it would most typically look like this. You have your edge devices producing the event data, something like a sensor measuring temperature. And then in most of the cases, you would bring this data into a message bus layer. So something like Kafka, like Azure Event Hubs, like AWS Kinesis. And then on the Lakehouse side in Databricks, you would have a Spark structured streaming job that is reading from this message bus and writing the data into the Delta tables. And this still definitely makes sense for many use cases, especially if you have also other applications reading from this same Kafka stream to also consume the data in near real time. But if your solely target is the Lakehouse architecture, you can now with Zerobus Ingest simplify this whole architecture because you can completely eliminate this step in between. So you don't need to maintain this message bus and maintain your Spark structured streaming pipeline to read from this message bus, which also has to be up and running 24/7 if you really want to have near real time. Instead, you can now use Zerobus Ingest to just directly push data into your Delta tables in Databricks. There are different ways to do so. In this video, we will focus on the Python SDK. So we will look into how we can directly push our data into Delta tables. And we see that it will be there in near real time. This feature is currently in gated public preview and will be available for everyone very soon. If you want to try it out right now, reach out to your Databricks account team and then they can enable it for your workspace. All right, so we move over to Databricks and the first thing that we do is we open the SQL editor and then we will create our target table where we want to stream the data into. So we will create a catalog, we will create a schema, and then we create the actual table and we can now already go ahead and execute this. And there we go. And as you see, this is a normal Delta table. So there is nothing special about it. We just created this table called air quality with a device name, with the temperature, humidity, as well as a timestamp. And this will be our target table where we will push data into using Zerobus Ingest. And we can query from this table to see that it is currently empty. And this will change in a bit once we start ingesting data here. Next step for us is to create a service principal, so a technical user within Databricks that we will then use to authenticate against Databricks and to push data into this table. For this, we move over to the settings right here. We go to the identity and access, and then we see here the service principals and click here into manage and add service principal, add new, and then we can provide the name right here. We call it Zerobus Ingest Sensor Demo. We add it right here, and then we can search for it again. We click into it, and we can generate a secret because this is the OAuth secret that we will need in our client that will push the data into this table so that it can securely connect, generate new tokens whenever needed automatically, and we don't need to handle the token refresh and things like that ourselves. So we generate a secret here, we can give it a lifetime, and there we go. We get a secret and a client ID, and we should copy over this secret here right now, as we will need it in a second. Now there's one more thing to do before we go ahead and write our client. We have to provide the proper permissions to our table to this service principal that we just created. And for this, we click into the catalog, go into the permissions, and grant to our service principal the required permissions. So we search for it right here, select it. The service principal requires the following permissions. It needs use catalog. And then on the schema side, we need to grant to the same service principal use schema. And then on the table level, all the service principal would need is, we select it here again, all what the service principal needs is select as well as modify. Cool, now we confirm this, and now the service principal has all the access needed to push data to this table. So we can go ahead with the actual setup of the client. To do that, we need to install the Databricks Zerobus Ingest SDK first. as we will look into the Python SDK approach. We see it's already installed in my case. Now, the first thing that I do here is I export the Databricks client as well as the secret as environment variables. And this is what we just have generated for the service principal within Databricks. And this way I don't have to hard code it anywhere in my environment. So now we will be executing the following code right here. We will be using this generate protobuf function that is part of the SDK to generate, as the name indicates, a protobuf definition of our Unity catalog table. And for this, we specify the Unity catalog endpoint, which is essentially our Databricks workspace URL. And we provide the client ID and secret ID of the service principal that we just exported as environment variables, provide the table name, and then how the output file should be called. And we had a small typo here. And then we see we have successfully a file generated. And indeed, we see here this record.proto file. We can have a small look into it. And this is what was generated by this function. So we could have also just generated this ourselves, but this small helper function did this based on the schema of our table, because the SDK is using protobuf to transmit the data in binary format, and therefore we need to provide this protobuf definition. Now let's actually switch from this ugly terminal into a proper IDE to execute the next steps. Now I am in VS Code and I just opened the folder and the file that was just created. And now we need to implement the actual client that will push the data into the Unity catalog table. But first, there is one more thing that we need to execute in the terminal. You also find all of this in the Databricks documentation. We also need to install this gRPC tool here, which is essentially our protobuffer compiler for Python. And then we need to execute this command right here. And this will generate for us a file that we will need. There we go, successfully created. And then you see here, we have the compiled protobuf file in Python. All right, time to create the actual client. For this, we just call this client.py. And we paste this code from the Databricks documentation, because you don't have to do the work if someone already did it for you. This is now utilizing the Zerobus SDK to push data into our table. We need to adjust a couple of things here. So we need to specify this server endpoint, workspace URL, table name, again, client ID, secret ID. For the client and secret, I will just use the environment variable. And now I also update all of the other things here. Here I need to put my workspace URL that I just copy pasted. Here I need to change two things. For the server endpoint, I need to put here my workspace ID, and then I need to put here the right region where this workspace is deployed. In this case, it is correct for me. I provide the right table name right over here. All right, now for the rest of the code, I need to tweak a few things here and there, because I don't want to go with this sample code that was provided here, because this is just an example here how it could work, but I already see that I would like to do things a bit differently. So here in this case, we are just ingesting some sample records, and you can also follow along and do it like this. In my case, I would like to ingest data from a real sensor. What I have done here is I have connected my Raspberry Pi actually to a real temperature sensor, and we would like to use our real sensor data here. And I also have a slightly different schema here, because I also have the timestamp. So I need to tweak the things here a bit. So I will just delete this part here for now. And what I will do is I implement a small function called get sensor data. In this case, this is fetching real sensor data from an API that I expose on my Raspberry Pi. Now again, let's check how can we access now the data from the sensor in our script. In my case, as I have some networking restrictions to connect to my workspace, I have implemented a short workaround, but for you, it would be even simpler. So in my case, what I do is I have implemented this small Flask API here that is returning me the current sensor data, right? And this is exposed as an API. Again, in your case, if you do the Zerobus SDK client directly on the Raspberry Pi, right, which should work in most cases, as you can also directly connect to Databricks there. In my specific case, I do it like this, that I start this API right here. And then in my actual script here, I am accessing the data right from this exposed API, right? Then I see here we also need to tweak this one as it is called air quality in our case. Now I will configure a few other parameters. I will give it a device name. This will be one of the column values that I also would like to send. And then now I'm pasting here a bunch of code. And what this is essentially doing, it is a continuously running loop, which is getting the humidity and temperature data from my get sensor data function, which is again getting real sensor data from my Raspberry Pi. Then I am creating my records here by using the device name, using the temperature and humidity that I extracted from the sensor, as well as setting a current timestamp. And then all I have to do is to execute stream.ingest record and pass the record along. And that's it. So this is the most important part here. You could tweak this however you like and send whatever data you like. You just have to make sure your protobuf that you generated initially matches the schema of your target delta table, and then you can do here whatever you want. In my case, I'm reading real sensor data in and ingesting it like this. Cool. And that's already it, basically. Right, so once you have everything set up, it's super simple. So we save this, we open our terminal again, and now maybe let's look at it side by side here. On my left-hand side, I have my script. On my right-hand side, I have Databricks, and maybe let's do one final check here. So I will query this table here called air quality. We see we have no records in here. Now I will start the execution of our client right here. It will establish the stream connection, and then it will start sending data. And now we can already go ahead and select count on this table. And there we go. We're receiving data in near real time, so I can keep refreshing this right here. Typically, the latency, what I experienced is like 1 to 5 seconds until the records are there. So it's near real time ingestion. And we can also have a look here and query the actual table. And in this case, I'm ordering it by the timestamp. Maybe let's make this one bigger now again. So the script is still running in the background. And now we can keep querying this, and we see the actual sensor data updating. And now what I can do, as I have connected this to a real sensor, is I can basically increase the temperature. And then if I re-execute this statement right here, you'll see that all of the records now will have an increased temperature. We have now already over 500 records, and all of this without a message bus in between, just using the new Zerobus Ingest functionality and the Python SDK for it. All right, and that's all that I wanted to show you for this video. So we have seen how we can set up Zerobus to ingest data into Databricks directly using the Zerobus Python SDK, allowing us to push data directly into Delta tables without the need to have a message bus in between and without the need to have a continuously running Spark structured streaming pipeline on the Databricks side. We just push the data and it's available there in near real time. Awesome. Now that we have this Zerobus ingest pipeline that will bring our sensor data into Databricks and write it into the Delta tables, we want to actually use this data. And for this, we will do two things. First of all, we will write a small pipeline that will take our sensor data inputs and will aggregate them by second. So currently it could happen that we get like tens of sensor data points per second, and we want to reduce a bit the amount of data. So we will aggregate the temperature and humidity per second and store this in a separate Delta table. And then we would like to build a Databricks app on top to visualize this data in near real time. And for this, we will also need a Lakebase database. So this is what we're going to also create next to not only aggregate the data, but also write those aggregations or sync those aggregations into our Lakebase database. All right, back in Databricks. So first of all, as you can see, the data is empty now as I truncated the table. We will later on re-ingest some fresh data here. But what I want to do now is I would want to create a new table called air quality aggregated. And this is where I will store the aggregated temperature and humidity values together with a timestamp and together with a record count. So let's say I get like 10 temperature values per second, then it will take the average of that, store it here and store 10, for example, in this column right here. And then I do also one more thing, and this will be important later on if we sync this table to Lakebase. We need to enable the change data feed for this table so that our pipeline that will do the sync between Lakebase and between our Delta table knows exactly what are the incremental changes that happen on this table here, and will then use this information to sync it very performantly by only taking the new values that come in. Cool, let's create this table first of all. Table created. It is empty for now because we did not write any data in here yet. And now we will write a new Spark structured streaming notebook that will continuously fill this table, and that will also do the sync with Lakebase. So for this, we click here on new notebook and we go ahead with the next part. Now for this pipeline, we'll be implementing it using PySpark and Spark structured streaming. So for this, we will first of all import a couple of libraries that we need, and we will start by reading from our Zerobus table. So this is the table we are pushing the data into using Zerobus Ingest, and we will continuously read from here to aggregate the values and persist them in a separate table. For the actual aggregation, we will be executing the following code here, which is, I think, pretty straightforward. So this is a very basic Spark structured streaming query that we execute here. And all we essentially do is that we, first of all, cast a couple of values here, because as part of this step, we not only want to aggregate the values, we also want to optimize a bit the table schema, and therefore we also include like this kind of cleanup step here as well. So we read in from this data frame, right, which is our initial table. We will be casting the temperature and humidity to double, right? We will add a watermark, right? So this is a Spark structured streaming pipeline, you can add this watermark to make sure that some late arriving events are considered here as well. We don't want to make this too big of a time frame because we want to ideally have a near real-time dashboard later on. And then we add the group by and average here. So we want to average the temperature, as I mentioned, the humidity, and then we also additionally store how many records this average here consists of, right? So it could be 10 records sent in 1 second, and then this will have the value 10 together with the numeric and humidity one here. And then we select what we want to have in our target output data frame, and that's already it. Again, we do this for two reasons here, right? We are improving the quality of our data by casting it into proper data types. Also, we are aggregating to reduce the overall amount of data that we also need to sync to Lakebase. In this case, it's like a couple of records I get per second. Imagine you get like 100 sensor data points for 1 second. You don't want to keep everything. You want to just maybe aggregate it and keep the aggregated value. Could be per 5 seconds, could be per 10 seconds, could be per minute. In our case, as we want to have this as real time as possible, we keep this 500 milliseconds here. And then to actually write it into our output table, we need to do one more thing. So we take this aggregated data frame that we built here, and we execute the write stream command. And we need to provide here a checkpoint location for the stream. For this, we will quickly create a new volume in our catalog. So we move over to the Unity catalog and we create a new volume, and we can call it streaming checkpoint, for example. And then we copy the path from here and paste it over here. Awesome, let's test it out. For this, I will start now again my script in the background to push data into this table right here that I cleaned before. That should get data now already. Perfect. This works. And now we can start our continuously running Spark structured streaming job here as well, which will now read from this table that we push data into using Zerobus, and it will clean it up, meaning putting it into proper data types, and then it will group the values and aggregate the values every half second and output it into our other table. All right, let's have a look. Looks like it's running here. So now we can also check out our other table. And we see also data is written into right here. And we see here it's a bit different. It's writing the data, if we order here by timestamp, every half a second, right? It's averaging the temperature, it's averaging the humidity, and it shows us the amount of records here. In this case, it's like 6 to 10 records that we send per second. Therefore, there are 3 to 4 or sometimes 5 in every 500 milliseconds. Now that we are creating this aggregated table here in the stream, we also want to sync it to Lakebase. Maybe to elaborate once more on Lakebase. So if you're not aware what is Lakebase, you can think of Lakebase as a Postgres database, so a relational database that was optimized for the lakehouse architecture. And the reason we would need Lakebase here is because we want to build this app on top that needs really low latency access to our data. And this is typically a great use case for a relational database, in this case for Lakebase, because as we're getting the streaming data in, we don't want from our app to read always from our plain delta tables in object store that would introduce some additional latency. Instead, we would want to have this quick millisecond lookups into the most recent values in Lakebase. And therefore, we want to have this relational Lakebase Postgres tables as a next step. For this, we need to do two things. We need to create the database and we need to sync our air quality aggregated delta table to Lakebase continuously. To create a Lakebase database, we move over to compute right here. And on the very right, you see here already Lakebase Postgres. And it is super simple. So all you have to do is you create a database instance. In our case, we can call it sensor project Lakebase right here. We can give it a capacity unit. So behind this capacity unit is the power of the actual compute behind it, how much CPUs and also how much RAM those machines have. There is a new version of Lakebase that can even scale to 0 automatically. This is currently in the beta stage. For this project, we will focus on the already in public preview available Lakebase instance. And for the other settings, we don't need to change anything. So we can go ahead and we can create this database. Cool, database created. Permissions we will need to look into later on if we connect the app to this Lakebase database. For now, this is fine. And now we need to sync our aggregated delta table to this Lakebase database, right? For this, there are different ways how we could approach that. Let me first show you the easiest one. For this, we go into the Unity catalog, and right from here, I could sync the table to Lakebase. So I could select here my air quality aggregated table, so the one that is aggregating every half a second, and I could create what is known as a synced table here, and then I could give it a name. And this will be the name how it appears in my normal Unity catalog. So I just copy the name over and append a synced here. And then what I can do here, I can select a database instance. And here I just select the one that we just created. And now I select also a primary key here. As we don't really have a primary key, we can just make it a combination of device name and timestamp, for example. And then in my use case, I would need a continuously syncing pipeline here because I want to visualize things in near real time. However, this sync has also a little bit of latency. So if I would go ahead now this way here and create this pipeline, it would be around 15 seconds of latency when the sync happens between my delta table and between the Lakebase table. Because I want to further reduce this latency and make it really a near real-time visualization in my app later on, I will take a different approach. So I will not create this here, but I also just wanted to show you this option here. This will be the easier option and it will most likely enough for most of the use cases to have a sync every 15 seconds. All right, so instead, what we want to do is we want to do the sync continuously in a Spark structured streaming pipeline that we maintain ourselves. And for this, we don't need to write everything from scratch. There's this Git repository here, which is called Lakebase for each writer. And this is what we are going to use. So we will copy the code here, and then we will just paste it in our previous notebook to do the sync with Lakebase continuously. And this way we will get a lower latency compared to the out-of-the-box sync that is provided through the UI, for example. The easiest way to set this up is just to go into this Lakebase for each writer here. You see it's also no magic that is happening. It's just basically already a pre-implemented solution to do the sync from our pipeline manually instead of using the out-of-the-box methodology. And all we have to do is we download this file right here, and then we will import it into our notebook. So back in Databricks and back in our notebook that we were working on previously, I will now simply import this file here that we just downloaded. There we go. Let's clean up the file name. Cool. And then here we just copy pasted it basically into Databricks. And now we can go ahead and use this in our pipeline. For this, I open again this notebook here that is still running, that is still creating aggregations continuously. And here we will add another step. First of all, we need to create the empty table in Postgres. For this, we move over to the query editor in Databricks. And this query editor was recently extended to not only support, like, let's say, normal SQL warehouses. You can also select there your Postgres database. And everything you execute here will be executed against the Postgres database, right? So what we will do now here is we will create the table that we need to sync the data. So we will go ahead and create this table right here, and this will be created in Postgres, in this Databricks Postgres database, in the public schema, and we call it Air Quality Aggregated Lakebase. And then all we have to do here is we have to use this for each writer. So the one that we imported from the other file. And then all I need to do is put in the proper values right here. I already specified the right table here. So we are in Databricks Postgres public and then Air Quality Aggregated Lakebase. So this is the table that we just created in the Postgres editor. For the data frame, we take the aggregated data frame. So the one that is continuously aggregating the data that we specified earlier. And then there is also host that I specify, as well as username and password. So where did I get the host from and what do I put here for username and password? For this, again, we go to compute, Lakebase, and then we click into our database here. And in connection details, you already see the host. So this is where I copied this value from. For username, we just can take it from here. Instead, we could also create a database user with a password. For now, we are just taking this one here and we paste it right over here. And then for password, what we can do is, again, going back to the earlier UI, we can here create an OAuth token for PG password, as you can see here. And this is what I can do now. I can click here and then I copy it over. And for simplicity reasons, I will just directly paste it here. Ideally, obviously, in a production scenario, you would not just copy paste the raw values here into the notebook. But for simplicity reasons, let's do it like this. And that is already it, right? So now we can go ahead and also start this stream here that will read continuously from our aggregated delta table and sync it to our Lakebase database. And to check if this actually works, we can already go ahead here and start a new query on the Lakebase database. And we just do a select star from our Lakebase table right here. And there we go. We see the values right over here. Cool. Now we have our pipeline set up to also sync our data to Lakebase. And now we can spend some time to build our actual Databricks app to visualize this data in near real time. Vibe coding a web application, meaning writing the whole web app using AI, is not a joke anymore, because recently models as well as tooling has become super good, and you can basically create beautiful looking web applications without a web developer background within minutes. And the good thing is, with Databricks apps, you can now build data and AI powered applications directly within Databricks, with easy access to all of your data that anyways sits within Databricks. However, probably everyone who has tried to vibe code a Databricks app or to vibe code any other web application has likely run into several problems. So things that I encounter often is your app runs super smoothly locally, but then once you deploy it, you run into several errors. And also sometimes you run into this endless error loop and you cannot properly debug your code. And probably the biggest drawback that I see is that often the code that is generated, especially if it's generated from scratch, does not have a proper structure and is not necessarily built on the most up-to-date frameworks and toolings, and you run into problems once you try to extend and scale your application. That's why in this video I want to show you how I vibe code a Databricks app, making use of recent frameworks that were introduced as well as the newest version of Cursor, where I show you end-to-end how I set it up, what my prompts are, what models I use, and how my end-to-end workflow looks like, to then deploy a good-looking Databricks app that also has some decent code behind it. By the end of this video, we will build a Databricks app that will visualize some sensor data in near real time, also leveraging Lakebase under the hood, and it will also provide a natural language interface powered by Genie to chat with our data within the app. Let's get right into it. Alright, and our journey for a proper Databricks app does not start in Databricks or in Cursor. Actually, I start all of my new Databricks apps projects by cloning this Databricks solution repository called APX. APX is basically a toolkit which was implemented by one of my colleagues. So shoutouts to Ivan Trusov for creating this. And as it's basically indicating here, it bundles together a set of tools and libraries to already have a proper framework for a good working Databricks app. What you should try to avoid is just starting from scratch and basically let AI implement the basic framework and everything around it for you. Instead, if you use this toolkit here, it will already give you a proper modern base structure. That means it will use modern UI libraries. In this case, it's using ShadCN and Tailwind. It will have a properly set up fast API backend. It will use UV and Bun for proper dependency management. So basically lots of different libraries and components stitched together, put into this framework, so that once you start from this, you get a properly set up framework already and you don't need to start from scratch. And this is already reducing many errors that you would run into when you set it up basically from scratch. Additionally, you will see in a second, it is optimized for vibe coding, meaning it has already some pre-configured cursor rules that will be used. It will right away connect Cursor to some MCP servers to make your vibe coding experience more reliable. So this is just a super nice starting point. I cannot go into all of the details, but I will link the repository in the description so you can have a look yourself and just follow the instructions, which is also what we are going to do next. So now I am in Cursor. This is my preferred editor for vibe coding, and the first thing I will do is I created a new folder here, and I will now install here this APX framework. For this, I will execute this command right here. All right, and then I'm guided through a couple of questions. So I provide the name of my app here. I call it Sensor Magic. Then it's asking me if I want to build a essential or a stateful app. For a stateful app, it will additionally create for me a Lakebase database, and we're going to use that. Next, for the profile, and this is referring to the Databricks profile. So ideally, you have already authenticated against the Databricks CLI and created the profile, and this is what you can specify here, so that once we deploy resources to Databricks, it is using this profile. And then around AI assistant rules. So this is what I meant earlier, that there are even some cursor rules already pre-implemented for us. And we definitely want to use that. And here we are specifying that we are using cursor for this project. We do not need a sidebar. And there we go. Now the framework is getting built for us. Basically, the project is being set up. And then after a couple of seconds, we see these two pop-ups here. So we see that two MCP servers were detected, and I would like to enable both of them. And there we go. So if we go to the editor now and we show the files, we see from our initially empty project, we have now a bunch of different files. And I don't want to go into all of the details, but essentially you have your source folder here with the backend and UI code, and you see already pre-implemented files such as a logger. We have some dependency management here. We have some utils pre-implemented here. And this is what I meant with we start already with a proper foundation, and then we build with our prompts on top of that. Apart from these components here, we have two more things that we would like to look into. So first of all, we also have a Databricks.yaml, and this is a Databricks asset bundle. For those of you not familiar, Databricks asset bundles is the preferred way to deploy non-static resources that you wouldn't like to deploy with Terraform, such as jobs, such as also Databricks apps here. And you see that already in this case, as we chose to have a stateful app, it would also create a database for us. In our case, we will already start with a pre-created database, so we don't need this part right here. And also our instance is called slightly different. So if you were following one of the previous videos, you would see that this is called actually Sensor Project Lakebase. And the rest can stay as is. And then there is one more thing that we would like to look into. First of all, we have a couple of MCP servers installed here. And I see we have this one twice and this one with an error. So we will remove those. So we have the chatCN MCP server, which will give our AI assistant the power to execute all of these functions here coming from the MCP server to give us back all the information that we need around the UI components that do exist. And we have the APX one as well, which has some pre-configured functions for us. And then the rules that I was referring to, you see that we have some project rules here defined. And this also gives our AI assistant already a proper framework around what are do's, what are don'ts, how do I go about package management, how do I structure my project, what are some general front-end rules like proper routing, data fetching, some patterns, what are the development commands, so how do I stop my server, how do I start it, and all of this is already preset for us. And this is super valuable because you don't need to come up with all of this yourself, but all projects would need something like this to properly vibe code and to guide the LLMs a bit with all of these rules that we give to them. All right, now let's get started and build our app. And the way I do it typically is with this new agents UI coming with Cursor 2.0. Typically, I create new agents if I am implementing different features, right? So if you create a new agent, you get a new context there. So I wouldn't do everything within one agent. I do now, for example, the initial setup with one of the agents. But then if I start to add more and more features, I typically create new agents for these new features. And then if it comes to these two settings here, you see here we can select between agent, plan, and ask. And this basically applies to any app you vibe code, not specifically to Databricks apps only. But the way I do it, most of the time, especially if I start with the initial prompt, I start with the planning mode because this will make sure that the AI behind it properly thinks through what needs to be done instead of just directly going to execution mode. And for this, to be honest, I did not test the plan yet with the new Opus model, but so far what I have done is I used GPT for planning and I used the Claude models for the actual execution in the agent mode, right? So I would use the new Opus 4.5 as an agent, but for planning, I mostly still rely on the GPT models. Okay, now I type my prompt right over here, and I specify all of that text here. Essentially, I'm saying I want to create an app to visualize my sensor data. I also described that it should start with mocking the backend data, right? So that for the local deployment, we get at least some data visualized. Later, we will change it to use proper data from Lakebase. And I'm describing how my app should look like. So in this case, I want 3 boxes showing the average temperature, humidity, of the last 10 minutes, last hour, and daily average. And then below, I want to have 2 graphs, which automatically refresh every half a second. I describe where to get this data from, and I do not need some kind of pre-screen. I just want to directly go into this UI here. I could even make this way more detailed. For now, let's just take this as that, and let's start the planning, and let's see what the GPT model comes up with for this app. And you see, as we are going in planning mode, it does not go ahead and directly create everything. It is actually asking us follow-up questions that it needs to have clarified before actually doing anything here. So what I will do now, I will go ahead and answer all of these questions right here by just selecting basically what I need. So for number 1, it is asking about how my data is already stored and if I already have maybe a database, and I will let it know I already have a Lakebase database called Sensor Project Lakebase, and I will also even give some more information about my table that already exists there as well. So if you have been watching the previous videos, I already created a Lakebase table where I stream some sensor data in, and I would like this app to use exactly this table. So I am telling it I have already a table with this name right here, and it has the following definition. And I even pasted the create table statement that I executed earlier. For the chat, it is asking me how I would like to do this. For now, I wanted to just mock it. For now, mock it. Later, we will use the Genie API. And that's it. And I give it back to the LLM. And let's see how it plans the next moves. And there we go. A plan is built for us how to design this application. And it will take into consideration my current baseline code that I got from the APX installation. And now it will describe me exactly how it will build it. And I can review this plan now and then let it build afterwards. So this is what I do now. I spend a couple of minutes to go through this plan and to decide if it makes sense for me or if I want to tweak a couple of things for now. And then I will build it. Cool, that looks good to me. And by the way, there is one more thing that I, in the meantime, configured here. Because I also want to use the new built-in browser tooling of the new cursor version. And here I enabled this and I put browser tab here. So we can now build this and see it right in cursor and also make adjustments right in cursor by pointing to what we would like to have adjusted. So now I select the Opus model in my case and I click on build plan. Now you see it has successfully built the first version, and now it even uses the built-in browser functionality to test things out in the UI itself, right? So it opened the app that it first deployed locally, and now it's even testing, and I don't have to do anything, right? I'm just watching what AI is doing here, basically. So it is seeing that we have some error messages here. It's failed to load the sensor overview. Then it's fixing, it's rechecking. Now it asks me to restart it, basically. I give it the permissions to do so. Now it's restarting the server. It will look at it again, and it will see if still the error is there or not, basically. You see connection failed. It's identifying, okay, it's not loading currently. It tries to fix it. It identifies the frontend is at another port now. It again opens it right here. Still, you see some errors that occur. It's also, by the way, checking the logs. So it's not only visually looking at the app, it checks the actual logs to see what might be the problem why it is not loading. Here, for example, it's now executing the run APX dev logs. And this was one of the rules that were provided in our rule stack. And now there you go. We see already the graphs are loading now. Let's see if AI is happy or not. We see still at the top, there is an error code. So probably it will still try to fix that now. But at least the graphs are already loading now and they look pretty good. And then this was fixed here as well. Awesome. It's running some browser actions. You see it's like trying to click around and test the things out. It's still not happy with a few things. Maybe something in the logs is still indicating some problems here. And there we go. Looks like AI is happy. So it's saying the dashboard looks beautiful. Now it's even testing the chat feature. So it's really going there and checking the current screen, how it looks like, and tries to fix everything. So basically a lot of the manual things that you had to take care of earlier by like screenshotting your web application or by giving it the logs, it's doing all of that automatically because it has this built-in browser feature. It has access to the logs. So it is debugging and fixing everything by itself. And I can just watch basically how the magic is happening. Now it looks like all tests have been passed. So it is loading the content, taking a final screenshot, taking a look at the screenshot, and it comes to the conclusion the dashboard works beautifully. So I already see a couple of things before I deploy this now into my Databricks app that I would like to adjust here. And the way I would do that here is I would first of all create a new agent, right? So I would not directly use this existing agent that did already all of this heavy lifting stuff. Instead, I would just use this new one here. And first thing that I would like to change is that I would like to have this assistant here only as a pop-up, right? If I click on an icon here, so it does not have to be there continuously. And another thing that I would like to fix is that this dashboard is like jumping so much, even though the temperature changes of the mock data are super small. So to fix that, I open a new agent. And then what I can do now, I can also use this new browser feature of cursor. And I can click here on select element. And I can just select my whole chat interface here that I would like to change, right? And as this is not super complicated, I will go ahead directly with the Opus model. I will not have a planning step before. I want this to be a pop-up, make it a round icon. It will open if I click into it. And then these two graphs should take the whole width. I execute it. And then let's see what AI is doing for us here to fix that. And there we go. So now we see already we have this icon here that we can pop up. It is testing the changes as well again itself. It makes a screenshot of the browser actually to also check it visually, not only in the logs. It's opening the chat window by itself, so I didn't click anywhere. And it is happy with the results. I could, by the way, always check what it is doing, right? In this case, I'm just accepting it all, but I could always like go in the actual code, see what was added here, check if it makes sense. Probably I would also do this to at least some extent, especially if I do some critical adjustments. But for now, I am a true vibe coder and I just accept everything that comes in here. By the way, it also added like this functionality to switch between light mode and dark mode, which I also like a lot. Now let me change the other thing that I mentioned. So what I do not like yet is that these two graphs, they are a bit too hectic for me. So I described that I don't like that these graphs are behaving like this. I want to make it a bit more smooth for especially smaller changes. So I've give that as a feedback together with pointing to these two graphs here. Now again, the other agent is trying to understand the context and it is planning the next moves and will do then adjustments again for us and test it out. This time I'm not super happy with the results, so it still looks not so smooth. So I will give it this feedback now. Okay, looks like it found the issue. So it seems like for the mock data implementation, it's every half a second generating a completely new graph instead of only generating the new data basically. And this looks way, way better here. So this is exactly how I envisioned it to look like. So now every half a second, it is basically only showing the new data coming in here much more smoothly. So before I deploy now to a Databricks app, let me actually ask it a question. So this is the third option that we can also select here. For this, I can create a new agent and I ask it. So I'm curious if it actually already implemented also the prod version of using like the real Lakebase data once I deploy into a proper Databricks app, or if it's still always like using mock data. Now it's scanning the code and trying to give me an answer for that. Okay, so now it's explaining to me without me having to scan all of the code. There is an environment variable use mock data, and I need to set in my Databricks app configurations the use mock data to false, and then it will actually connect to Lakebase. Okay, that sounds good. Now I have one more follow-up question. So I would like to know, how do we plan to authenticate against the database? So I will ask, how does authentication to Lakebase work? To also make sure this is properly set up using a secure setup. And I get a response back here with the information that it is using OAuth access tokens. Even though it looked good, to be on the safe side, I will use the Databricks Apps Cookbook, and this is essentially a collection of lots of very useful recipes for common scenarios. So I highly recommend this. I will also put a link to the cookbook into the description. And what we have here is we have a recipe for connecting Fast API to Lakebase. And what I can do is I can just copy that code. I will go over to Cursor, and then I will tell it to compare this implementation with what I just copy pasted. There you go. So this is like how I typically work. So if I know already some critical points of the application where I already have like some code snippets, or I already have like the best practice code, I will just give it to the AI directly. And there you see already it identified quite a lot of gaps compared to my best practice implementation. So now it will go ahead and refactor the actual code. Cool, the changes were implemented. Now I can finally go ahead and deploy this app to a Databricks app to see if it actually works there as well. For this, again, I open a new agent in the agent mode using the Opus model. And then all I'm going to specify is deploy this as an actual Databricks app. Make sure to use actual Lakebase data instead of mock data. Now we see the Databricks bundle deploy command is being executed. So it's actually trying now to deploy the app, but it's a bit confused with the profiles. And now it picks up the right profile here. All right, now the app is successfully deployed. I was running into some issues because I already deployed this earlier, and it got confused a bit with the Terraform state, but eventually it figured it out. And now let's check what is there in Databricks. For this, let me switch back over here, and then I filter by my apps, and I see here this Sensor Magic V2 right here. I still need to start it, right? So this did not happen yet. I could also prompt my agent now to do so, but I will just do it from the UI. And this takes a couple of minutes, and then we will see if it will work out of the box, or we will need to further iterate with our vibe coding approach to make it work. And while we wait, we see already here that an app resource has been created referencing our database here with the can connect and create. We can click into this Lakebase project here. So this is the one we created in one of the earlier parts here. And this is the one that stores our sensor data. And If we go into the permissions here, we see here that a role has been added. And this is actually the service principal of my app here. You see it also here. This is like the ID of my app. And this matches what I see right here. And yeah, for now, let's just give also this user some more permissions. Now the app started and I can deploy it from here, but I would like my agent to do that because as we further iterate, I would also like the agent to deploy the app. So I'm telling it now the bundle was deployed and the app started. Please deploy the actual app now. Now it's executing the Databricks App deploy command here. All right, now we refresh this right here and we see our app is actually running. So we can click into it and it does not work. All right, how do we fix it now, right? So there are different ways to do that within Databricks. So I would typically look into the logs now and try to understand what the problem really is here. But what I can also do is I can give my agent access to all of these logs here. And this is something that was just very recently added to the Databricks SDK to easily read from the log files. And this is not yet built into my APX framework as a rule, for example. So I will just open a new agent here. And as this is so brand new, I will actually give it the exact command that needs to be run. For everyone watching this video, I would just add that also to the rules of the cursor setup. So I'm saying the deployed app does not work. Check logs using Databricks apps logs, and then the app name, and then the profile. Saying the issue is clear from the logs. There is a module not found exception. Therefore, it's rechecking if everything is configured as expected. And it figured out this needed file landed somehow in the git ignore. So now it will remove it from there and probably redeploy the application. And for that, I can actually go back to my agent that I used earlier to already deploy and just tell it to please redeploy. So now I can use one agent actually for deployment that already successfully deployed my app once. And then I can use the other app to troubleshoot that already knows how to read in the log information. So it's saying the redeployment was successful. So let's check it out. And we see it was just redeployed a couple of seconds ago, but it still does not work. So I'm going back to my agent, telling it it still does not work. Check the logs. And this is how it works, right? I don't want to make any false impressions here. So it's always like a back and forth. Sometimes you run into those errors that take a while to debug, but it's important that you know how to handle it. You give the agent access to your logs. It will try things out. It will redeploy. It will see if it worked successfully afterwards or not, right? And this is the way you typically work in this motion. Now at least it claims that my wheel includes this file that I need. Next error identified. Now the validate DB seems not to work. And this is a problem that could not be catched locally because now it tries to make the connection to the database actually. So we are on the right track here. So now it thinks it's super smart. It came to the conclusion that the easiest fix is just also to use mock data within the Databricks app. And now the deployment was therefore successful. It also checks the logs now again. And the app is now running, but it's using mock data. We will fix that in a second, but maybe let's have a look into the app. And we see indeed it was deployed now. Into a Databricks app, right? So here we are not operating locally anymore. We are actually in our Databricks app, but it's still not pulling our actual data because our AI was running there into issues and thought it's easier to just also use mock data and prod. But that is not what we want, so let's fix that. I want to use Lakebase data and prod and only mock data locally. Please try to fix my database issue. Now it's rebuilding, and we see again also our local app started to work again properly. All right, at least my agent claims that the database connection is now working successfully. So let's have a look. We are updating it. We see that the temperature is still here, and this is actually valid because the temperature in my room does not change that much. So what I can do now to test the dashboarding functionality is the following, because this app, if you have not been watching the previous parts, is actually connected to Lakebase, and the data lands into Lakebase from my real physical temperature sensor that I have right next to me, which is connected to a Raspberry Pi. So what I can do now is I can put my fingers onto the sensor right here. And as you can see, already something happens within the dashboard, and temperature should also increase now drastically. And there we go. So you see it's like a couple of seconds of delay, but it's all working. So my real-time dashboard is actually capturing my real data that is fed into Lakebase. So this part is now already working super good. Cool. And all of that vibe coded within a couple of minutes using our cursor setup. And I also like how it's now very smoothly showing the recent updates on the dashboard. Cool. So now that this is working, we can basically tackle the chat interface here. And let's actually have a look how it is currently being implemented. So as I did not give it any proper instructions yet to use Genie, I would expect this to not work yet. So if I'm asking like, how many spikes did I have in the last 10 minutes? It looks like it's just giving me a generic answer about the current readings here, right? So it's not really using Genie yet to query our data. And also I see here it's a bit buggy that I cannot ask any follow-up questions. So I need probably to reopen it, and only then I can ask follow-up questions. So let's fix that. Let's make our chat actually smart, and let's make it query our Genie space. So first of all, let us quickly set up the Genie space. So for that, I click here on New, and I will keep it super simple. So all I do here is I select my table, and in this case, let me actually collect the raw data here. So our Genie space will query the raw data. For this case, it will be only one table, right? It will be super simple. I will add some instructions here, and that's basically it, right? Obviously, it would be even better to have also more tables in this Genie space so that also the LLM behind it has more context, because this is again how Genie works, right? For those of you not familiar, Genie is our text to SQL assistant. Basically, we can ask questions in natural language. It will scan all of the metadata of the underlying tables that I linked in here. It will also look through the additional instructions that I put in here, and then it will use all of that context to come up with a SQL query, execute it, and give me the output. And this is what we want to include in the app as well. Let me add one instruction here. So I'm saying here, when someone asks for spikes, consider a spike over a 1 minute time frame rather than evaluating each individual data point, because later in our app, we would like to ask questions like how many spikes occurred within the last hour, and we don't want it to like give us back 1000 spikes or something just because 1000 data points were considered a spike. By the way, what is considered a spike? This is also a good one. Spike can be considered above 25 degrees or below 20 degrees. Cool, and that is already it here. I can basically ask this question here now to make sure it all works as expected. So I'm asking how many spikes occurred in the last hour. It is finding the right data. It is looking at the metadata of our table, and then it's generating the SQL query. And then you see here, the answer is there have been 3 spikes, right? And it's also asking me some follow-up questions, but let's look at the code. So it actually considered here a timestamp of 1 minute, and it's looking at values above 25 and below 20. So it's taking into consideration our comments here. Cool. Let's give this a name. Let's call it my sensor agent. Back in Cursor, I open a new agent. I start in planning mode. I select GPT 5.0, and now I describe basically what I would like to do. And for this, I define my prompt the following. Please properly implement the chat interface now. Earlier, you just mocked it. I want you to query a Genie space on Databricks. And for this, you can use the following example. And here again, I follow a similar approach as I was earlier with the OAuth configuration, because there is this Git repository that is already doing exactly what we want to do. So it's showing an example of a Databricks Genie API integration in a Databricks app. And because this work is already done here, the URL, I will just copy the URL of this Git repository, and then I will just paste it here. And then I can also specify you can clone it and investigate the implementation logic. Also make sure to add the permissions for the Genie space as an app resource. And that sounds good. So let's see how the plan will look like now. Now it's asking some valid questions like what Genie space should actually be used. And here I want to use an existing one. And it's even asking me about conversation state. So this is an interesting one because I don't want to keep it too complex for this demo here. I will just make it stateless so that each question is handled as an independent query. But if I would implement this for a production use case, probably a conversation state would make a lot of sense. And this is also something that I could, for example, store in Lakebase. Now it comes up with a plan, and this looks all good to me. One thing I'm curious about is which Genie space it plans to use, because I did not provide the name yet. So I will just be proactive this time and specify it here. So I'm saying build it. By the way, my Genie space is called my sensor agent with the following URL. And then I change it back here to agent and opus. And let's see what happens. So we're opening the dev UI and see that currently it's having some issues, but I would expect the AI to figure this out now itself again, how to fix it. And it's already looking at the logs here. So it's trying to submit now the question also locally, but this is actually not what I want. So I just stop it here and then I tell it locally it is fine to not call the actual Genie space. So I'm just saying it can give like a static response back, like locally Genie does not work. So that we can at least see how the UI behaves, but we don't actually test the Genie integration yet. This we will only check once we deploy it into a Databricks app again. Now let's test it if it actually works. And there we go. So this is what we expected. So next we can actually deploy it and test in the proper Databricks app. I will go back to my agent that I already used previously to deploy to Databricks. So I can tell it redeploy the latest version. Looks like it's redeployed. So let's have a look. All right. So I needed to fix a few permission things on the SQL warehouse as well as on the tables, but now it was redeployed and now we should be good to go. So let's ask again, how many spikes did occur in the last 3 hours? Now we see it is thinking. I would assume it's calling the Genie space here, and we get the answer of 3. Cool. And then maybe what is actually a spike, and then we get a spike is defined as a temperature above 25 degrees and below 20 degrees. Cool, so it all works as expected. We have our live temperature and humidity dashboard up and running. We even have a chat interface now to ask further analytical questions. And all of that was web coded super fast, just using Cursor, using APX as a framework, as well as using some best practices here and there, such as cursor rules and extracting the Databricks logs. I hope that was helpful. Also, let me know in the comments how your current web coding setup looks like. Maybe I missed something, or you can give me a hint where to improve on this workflow. And yeah, thanks for watching. I see you in the next video.